Okay, in this video we are doing Calc Problem Set 50. The problems and the playlist are in the description below. Also quite an accomplishment to make it 50, so congratulations if you're still here. If you're just starting here, go back to the playlist and do all the other ones. They will definitely give you a lot of practice going into the AP exam or going into any tests or quizzes you have in class or whatever. They're good calculus problems. So let's take a look. Use the table of values shown above for the differentiable. So differentiable implies continuous in case we need it. So we could use mean value theorem, or we could use the intermediate value theorem. Just thoughts you want to have to answer the question. So approximate f prime of 9, show the setup. All right, f prime of 9 is approximately. The approximately equal to sign really matters. Don't write equals there. You look at the table and you look for where 9 would fall. So it's going to be between 8 and 10. So I'll use the slope of the secant between 8 and 10. So f of 10 minus f of 8 over 10 minus 8, which is 17 minus 4 is 13 over 2. 13 over 2. All right, B, prove f prime is less than 0. So we have stuff about f. We also have stuff about f prime. It's not really obvious from looking at the row for f prime that f prime would ever be less than 0. So I'm going to use the row for f to prove something about f prime. That's the mean value theorem. So to use mean value theorem, I need continuous on the closed, differentiable on the open, but overall this is differentiable. So I'm just going to say f is differentiable, therefore continuous, or implies continuous. Therefore, by mean value theorem, 3 and 8 are adjacent. They're like right next to each other in the table, so there's really not much to think about here. We just try to do it. F prime of c equals f of 8 minus f of 3 over 8 minus 3. That's going to be 4 minus 21, which is negative 17 over 5. And that is negative. So I'm going to say that's for some c between 3 and 8. That's what the mean value theorem guaranteed. But then since that's negative, we can definitely say that f prime of x is less than 0 for some x between 3 and 8, because we know that at c, f prime is less than that. And that's between 3 and 8. So that'll come up a lot. Like, use mean value theorem a lot, I would say. Intermediate value theorem a lot. All right, use the tangent line at x equals 8 to approximate f of 8.2. This is like, it's almost insulting to be asked these questions at this point. And usually when I say something like that, I then get it wrong. So we'll see. But we need to know the value of the function and the derivative at 8. And we can just read those from the table. So f of 8 is definitely 4. F prime is definitely 5. So our tangent line in point slope form, y minus 4 is 5 quantity x minus 8. And then we just plug in, right? Make sure you're saying approximately. F of 8.2 is approximately 4 plus 5 times 8.2 minus 8. So that's 5 times 1/5, which is 1. So we get 5. All right, let's see what the next problem is, or the next part, I guess, in this case. Write the equation of the secant line. This is an Algebra 1 question. When somebody says write the equation of the secant line, they're just saying go back to Algebra 1. Here are 2 points. Write the equation of the line between them. That's all we're doing. So secant line between 3 and 25, which is spanning the entire table. This is a very wide range for a secant line. All right, so the slope is going to be f of 25 minus f of 3 over 25 minus 3. So that's 27 minus 21 is 6 over 22, which is 3 over 11. And then for secant lines, because you have 2 points, like a tangent line, you usually only have 1 point that you're really concerned with, which is the point of tangency. Here we have 2 points, so we could reasonably write this 2 different ways. So you could choose to use 25, 27 as your ordered pair, but you could also choose to use 3, 21. It doesn't make a difference. They'll give, and if you expand them, you'll get exactly the same thing, but like, why would you expand them? Like, I would use the first secant line if I had to approximate a value very close to 25. I would use the second one if I had to approximate a value very close to 3. And if it was in between, I don't know what I would choose. But it doesn't matter because we don't have to do it. All right, next one. If g of x equals f inverse of x, so g is the inverse of f, is f inverse. What is g prime of 23? All right, classic. So what you want to do is you need to figure out what point that corresponds to, right? So 23 is an x coordinate for g, which means it's a y coordinate for f because they're inverses. Since we know stuff about f, we just go to the table and figure out where's the y coordinate 23. And you can see that's when x is 16. So that's x for f of x, which means it's y for g of x. And now the relationship is g prime of 23 is going to be 1 over f prime of 16. So you got to find the corresponding point. You have to find the point, right? So the point on f is 1623. On G, it's 2316. F prime of 23, 1 over, G prime of 23 is 1 over F prime of 16. The more you think about it, the easier that gets. Like, I enjoy answering those questions. I look at those and I'm like, given the graph of a derivative, I pretty much feel like I'm like batting 100. The derivative of the inverse, I feel like I'm very close to batting 100 because it's like always the same thing and they're never really trick questions. They're just like, do this thing, demonstrate that you have this knowledge. All right, last question of this problem set. Find the first derivative of y equals arctan of root x. All right, the derivative of arctan is 1 over 1 plus u squared times the derivative of u. So I'm going to start with the derivative of u is 1/2 x to the negative 1/2. That's our numerator over 1 plus u squared. So 1 plus root x squared. And then, I don't know. You could totally leave that, but the 1/2, I'm going to make 1 over 2. I'll bring the 2 to the denominator, and then x to the negative 1/2 I'm also going to bring to the denominator. So overall, I'm going to write this as 2 root x and then quantity 1 plus x. So this one you'll see frequently later on in calculus where you have to like reverse it. And when you have to reverse this and go from this derivative back to the function, it's a little tricky if you don't look at it and think like, oh, 1 plus root x squared, we could be talking about arctan. So like, I think the sooner you see it in the progression, the better off you are. It's kind of why we're doing it here. But anyway, that's problem set. I hope this was helpful and good luck.